name's David Gammon. I'm Operations Director at Piston Performance Gearboxes, also PPG, here at PRI 2019. We've been coming to PRI for 7 years. We select PRI because it is the most relevant motorsport trade show in the world. The complete solution came about really driven off the back of the R35, which is quite weird really, because you get the Mustang Camaro, the Viper, all the big American muscle cars, and they've all got 6-speed manuals, and people want paddle shift. They want that DCT, that R35 feel, and you know what? That's what we delivered. We gave that to them. We take a gearbox, we evaluate it, and we make a complete gear system ready for the guy to go full paddle shift, go lever shift, anything they want, and they can go as mild or as wild as they want, and that's what we supply. We supply the dreams. The gears are the easy part for us. That's what we do. That's our bread and butter. So we tend to, a lot of people see straight cut and synchro and helical and dog and not really know what all that is. So the engagement is synchro or dog. So the sequentials are dog engagement. The actual tooth profile can be straight cut or helical. The helical we use a lot, especially on T56 and the R32 GDR sequential. Why? Because the gears are really, really wide and we get a good contact surface area, and it keeps the noise down in the cabin, and that really annoys people if it's too loud in their daily driving, which they do. The second thing is that sometimes the OEM, the bearing diameters and the widths and everything else can be increased by simple modifications using billet plates, intermediary plates and sandwich plates, and that's become more and more prevalent on every gear set now, every gear system. So in the sequential conversion, we use a motorsport barrel, few moving parts, and low friction, and that's the key in a PPG. It's low friction, low mass. I think the biggest single change on gearbox technology is it's all about the data. So at PPG we collaborated with a company called gearsets, a boutique British company. They supply fuel flow sensors and a lot of sensors for the Formula One industry. We want great data acquisition and visibility to the ECU. So we ended up with a contactless induction type 10-bit rotary position sensor. So the majority of the Hall effect sensors on the market, even some of the contactless ones, they don't have the resolution. So what happens is you can log them at 50 hertz or log them at 100 hertz, and then you have to apply filters. And what that does is that gives you an insecurity of knowing that data is correct. Our blade sensor can log at 1 kilohertz and it will give you a flat output. The more data we can give the ECU, the better the integrity of the shift, the repeatability and the uniformity, and that's the key advantage, and that's what makes the system. We have a rotary position sensor and we have a load cell. The rotary position sensor sits on the barrel, and what that does, it basically tells the ECU what the barrel is doing, so what position at any given location. In terms of a lever shift car, you have a load cell, and that sits on the bottom of the gear lever, or in the R32 case, it's actually integrated into the shift knob on the top of the lever. When you run a closed loop circuit, you use the load cell to initiate the cut. So you pull on the lever goes to a threshold force. The load cell is a 0 to 5 volt. We do a 0 to 12 volt now, actually mandated, because a lot of road cars, again, they can't get a 5 volt feed. The voltage is centered at like 2.5 volts. So what that means is we have an upshift voltage and a downshift voltage. So when we go upshift, the voltage goes high. When we go down, the voltage goes low. And again, the ECU can determine that. And we typically map that per gear, and we look at the way that the lever takes up any slack in the system. It starts to see micro movements on the barrel, and at which point that is the correct ignition cut strategy. With the 10-bit rotary sensor and the load cell, you can run several closed loop circuits on the gear shift strategy, which a lot of people don't really understand, but we try and implement them from a point of reliability and longevity, and that's typical for PPG. You will see these gearboxes in service for 4 and 5 years and no parts. The sensors do the work for you. They do not allow power on shifting, either upshift or downshift. And if the calibration's done right, then they shouldn't require parts. The gill blade sensor is a comms-based programmable sensor that you program when you install the gearbox. Usually you do it on the bench, and we made the decision to use all Deutsch connectors, they're proprietary Deutsch connectors, Autosport connectors like you use on any car. All the looms are DR25 loom. We use DTM connectors as and where possible, and it's an overloom that has a full detailed schematic in all our documentation, so you can not only integrate with that, you can bypass it if you really want. You know, engineers may build it into their loom, such as like the Lamborghini, and that gives you everything you need for integration into the ECU and into the chassis. With a lever shifter, you're using your hand to move a lever from A to B, which is X amount of distance, and a paddle shift, pushing a lever, you're pushing a button, you're tapping a paddle. It's an electrical function into the ECU, and the gearbox still moves in a mechanical fashion. Typically in PPG sequential, when we offer a paddle shift solution, it's no more than 4 to 6 bolts, and that's it. You take everything off and you put a pneumatic cylinder on, and then basically you have a connection with the ECU, and that is the difference. There's no other difference. It's really a case of it's actuated by a hand, by a lever into a rod, into the actuator, or it's pushed and pulled by a small cylinder, and that really is the only difference in a paddle shift or a lever shift sequential. The function of the ECU is very similar. You don't use a load cell on a paddle shift system, but that's a different strategy. In a lever shift sequential, your load cell says to the ECU, hey, I'm going to shift, whereas in a paddle shift you make an action and the system has to react. So typically a paddle shift system can be more aggressive than a lever system just from that very aspect, but what we've done in the past is actually fit a load cell in front of the pneumatic cylinder, so we can actually again have a pre-warning to the ECU. And I think it's just a case of being smart, and if you have the proper strategy and the proper calibration, then paddle shift can be absolutely sublime. It's in terms of longevity, it's the ultimate control, because you can never make a shift without the gearbox being controlled by its sensors. Our paddle shift systems vary. We have we typically use a two-way cylinder, and that requires an external valve body, and that will usually, if you have a motorsport ECU, you plug that straight into the ECU to control the flat shift and the throttle bipping. So the paddle shift options are T56 Tremec. We also do the Subaru Impreza STI WRX. We also have a system for Lamborghini that was done through Dallas Performance, but nonetheless available. And the latest one that's fresh off the drawing board is the R32, and that will be available early 2020. All the air compressors, they tend to be quite bulky, and this is where a lot of the energy for PPG going forward is actually we're moving to e-drive systems. So we're circumventing the pneumatic and going to essentially electric, and these will be more compact. There's only one moving part, and it's a Deutsch DTM with the power supplies and the control, and that's where PPG going. 2020, expect to see the first commercially available e-drive sequential on the market. If you're doing competition, drag racing, time attack, sprinting, think about this. In a rally team, we would every other rally pull the gearbox down and do a full service and change the bearings. So when you're in a motorsport application, doing your due diligence and basically your 5 Ps, really every couple of years you need to be looking at doing bearings. A bearing set's not a lot, it's a rebuild, it's a refresh, and that's the thing. And the other thing now, we work with KA sensors and work with Gill, and now you can get a small sensor that can be installed in the gearbox, and it's called a debris sensor, and that will detect any ferrous metal. So what can you do? You can link that to your ECU, and you can say, okay, I have 0 particles, and I've got a particulation build-up on my sensor, I better inspect it. And you can really avoid a lot of the ongoing maintenance schedules by fitting a debris sensor in your road-going gearbox linked into your ECU to give you warnings by having this, because then you know definitively there's no metal inside. You know what? It's good, we're good. Apart from the bearing thing, every couple of years, no problem. If you're drag racing, you need to be a bit more cautious and say, okay, the life expectancy of the parts, we build really strong gearboxes, but if you're putting them through massive torque loads, then you have to think about getting crack testing done on a regular basis, because the preventative aspect is profound in reliability. terms of service interval, we would say oil change every time you go to a big event. If you're doing a big event where you're drag racing all weekend, change the oil before you go. If you have a filtration system, change the oil filter. You should be okay for a couple of years in an R32 GDR. Doing the occasional event, you should be fine. It's only when you're doing extreme circuit racing, you know, you go for a track day and the track day turns out to be, you know, 80, 100 laps. That's when you need to think about not necessarily the gearbox, but the oil integrity. When you have those extremes, then you have to take on the burden that you need to be crack testing and doing your due diligence to make sure that you've got the reliability. The Texas Mile is a formidable event, and M2K and Mark Hideko and his team, they've gone 300. The first piston-powered car to go over 300 miles an hour. They actually did 306 miles an hour just after the finish, but they got a registered time of 300.4 miles an hour. And actually people are saying, oh, you know, because is it the Ferrari, the GD40 thing? It's no, actually when he went 300, we kind of had to give him the respect, and actually it's a master stroke. It's a master class, because I think it's one of the most, you know, sought after cars here at PRI 2019. They won the best boosted motor, PRI 2019. Obviously that's not us, we make gearboxes. Nonetheless, it's a lovely gold trophy. It's awarded by JE Pistons every year, and it's a fantastic accolade for the car, and we're honoured to be just a small part of this car's history.